So yeah, GKE, I mean, we just talk about Minikube, right? This is like something you can deploy on your laptop. Minikube start and you're running Kubernetes cluster on your laptop. There's kubeadm that actually, you can run in a cloud provider or somewhere like that. And there's like lots of other tools that deploys Kubernetes. But I think a lot of people who are just starting with Kubernetes and want having something production ready, there's nice Kubernetes from the GKE. So we have a quick demo how it works, and then we have a Google representative Atif with us. Yeah, you can come and ask questions if you have any. But yeah, it's Kubernetes birthday, so it's in Google. So we decided to have a little bit of Google cloud provider talks about how to run Kubernetes in Google.
Hi guys, can you hear me?
Yes.
Cool. So, hi everyone. I'm Patrick. I'm a customer engineer for Google Cloud working out of the Montreal office. So some of my colleagues from Toronto are with you guys. Since I'm standing between you and pizza, I'll try to make this quick. I don't have a lot of slides and we'll go into the live demo. So I'm here today to talk to you about Google Container Engine. So as Erad just said, one of the goals of Google Container Engine is to be the path of least resistance between you and a production grade Kubernetes. There is a lot of ways to deploy Kubernetes. There are some automated ways. There's kubeadm, there's cups, there's Minikube if you want something local, but a lot of those automated ways of deploying Kubernetes are actually not production ready. So the goal with Google Container Engine is try to get you to start using Kubernetes in an environment that is production grade with as little resistance as possible, so as fast as possible. And we'll try to do this in the demo, so we'll give ourselves about 10-15 minutes, time for the pizza to get there, and we will have a Kubernetes cluster running, started from scratch with a pod running in it within those 10-15 minutes. So before I go and do that, let's just start with what is GKE. So GKE is pretty much a managed Kubernetes cluster on Google infrastructure. So what you do when you leverage GKE is that you deploy open source Kubernetes. Actually, Google deploys open source Kubernetes for you, but you are leveraging Google's infrastructure. So as the previous presenter mentioned, Kubernetes actually comes from Google. It is an open source of our internal container orchestrator that's called Borg. So Google does know a lot about deploying and managing Kubernetes. We've been doing this for 18 years now, whereas people in the field have been doing it for maybe 2-3 years. So we have a lot of experience. So using GKE, you're actually leveraging that experience that Google has at managing container clusters in general and Kubernetes more precisely. Another very important point, it's based on open source Kubernetes. So in contrast to some of our competitors who actually have modified some container orchestrators for their cloud environment, when you are running on GKE, you are running the same version of Kubernetes as everyone else. There's no Googleification here. There's nothing that would prevent you from running the same workload on any other Kubernetes cluster. We support version 1.6 and 1.7. It's a fully managed solution. The other part that's great about running on Google infrastructure is that we can actually automatically scale for as large as you need. And I'll give us a small example of what that means in a couple seconds. But one of the biggest issue people run in running their own Kubernetes cluster on bare metal is how fast they are able to scale. So it is very hard to scale a Kubernetes cluster manually. You need to get your hardware, you need to do deployment, there's a lot of operational complexity around scaling, and GKE will allow you to do this and allow you to do this in a way that's smarter than some of the other deployment in the cloud would be. So there is some features that I will highlight later that will actually make that scaling smarter than just have an auto-scaling group with some instances in it. It's also automatically updated. It now supports automatic repair. So if there is monitoring built in, if any nodes goes down, if any nodes is outdated, we can actually rotate the nodes for you using our intelligent algorithm that I mentioned. So we're talking about scale. So to give you an idea of what scale you can use GKE in, Everyone has heard about Niantic, about Pokemon Go. It was a big thing about last year, so maybe 8-9 months ago. And the way that the people at Niantic and people internally at Google describes the launch of Pokemon Go is that it is a case study in art failure for ops people everywhere. And what do we mean by heart failure for ops people? That graph, which has been showed a few times, some of you might have seen that graph already, is very, gives a good image of what that means. So that little line at the bottom here actually shows what their launch target was in terms of transactions per second. The red line here was actually the worst case that they had estimated. They had sized for that worst case. And that green or yellow line, sorry, I'm colorblind, so I might be giving colors wrong, but that is the actual traffic that they hit within the first 12 hours of the launch. So what you have is within 12 hours, about 50 times the traffic that they had initially targeted in terms of transactions per second. This kind of scale is great. I mean, anyone who's launching a product would be extremely happy to have 50 times the traffic that they're expecting. It means that it's major success. But you want to make sure you do not fall to death by success. You do not want to be killed because you cannot handle the traffic. Even if you had estimated 5 times as your worst case, you are 50 times over. So this kind of scale is actually something that Google can help you with. So when we're talking about your ability to scale your cluster and to make sure your cluster will be available regardless of the load you will have on it, that's the kind of things that Google can help you with. But that's enough with boring slides and charts. I'm sure that you are way more interested in seeing what that actually means in practice. So I'm telling you, I have maybe 9-10 minutes left in the time that was given me. So let's see what we can do in those 10 minutes to try to get Kubernetes running. Anyone, and sorry, I can't see the room, so I cannot ask who booted up a Kubernetes cluster in the past, but any of you who actually tried to start up Kubernetes from scratch know that it can be a very long and extended amount of work to get to a running cluster. So let's do this. The only thing I did here is actually create a Google Cloud Platform project. I don't have anything running in it yet. We'll move into Container Engine, and we will come here and just try to create a container cluster. Actually, I'll take 1 more minute because I really had done nothing in that environment, and Container Engine API was not ready yet. So what's happening right now is that I'm bootstrapping the Google Cloud environment to be able to run containers. I haven't started cluster yet. I need to bootstrap the actual API, tell my project that yes, I will be running some container clusters on that project, and it is initializing the API. That normally takes about 30 seconds. It should be done soon. And once that's done, that will give me access to the API to start and provision that cluster. So I was mentioning open source Kubernetes earlier. There's actually 2 layers of API that we're using in Google Container Engine. There's the Google API that will allow you to manipulate the cluster itself. So that's the API that you will use to start your cluster, scale your cluster, change some features, change some settings. That's the Google API. And once your cluster is started using that API, you will see that we will be using some very standard Kubernetes API calls to make those requests. Since GUI is the most better than command line, I will actually be using the GUI to deploy the container cluster here. You can do the exact same thing that I will be doing with the GUI through either RESTful calls to the API or to the command line. So the ability to actually provision a full cluster in a small amount of time using either API or CLI is actually something that's extremely powerful. And that's powerful because that means that you can actually automate the creation of your clusters. I've seen some use cases for some short-term jobs where container clusters are created on demand. So rather than have a large pool of resources, which might not be fully utilized or which you might not need at all time, there is actually a way to use automation to, through the API, create your clusters on demand, deploy your jobs, and just shut down the cluster when you're done. It provisions fast enough for this to be an option. And since Google actually bills you by the minute rather than by the hour, if you run machines for a small period of time, let's say 10, 15 minutes, you will actually build a lot less than if you add that machine um, running for a long period of time when it was underutilized. So while I was babbling about those features, my API actually got initialized, so I can go and create a container cluster. So how do I do that? I will give my cluster a name. I will call it Cube Toronto. No description. I will choose where that cluster will run. Okay, I think it was not live demos. It's always the fun thing. Sorry, I'll just reload. My UI was not fully provisioned yet. Okay, cool. So I'll call this Cube Toronto. I can type. We'll choose a zone, so I'll put this in on the East
Patrick?
Coast.
Hi,
I will-
sorry to interrupt. Can you make your screen a little bit bigger?
Yeah.
Can you zoom in a little bit? Thanks.
That's better.
It's amazing.
Cool. So we'll choose 171 as the cluster version. We'll go with the latest version. And here we can actually choose the size of the machines. We can also go with custom machine size. So let's say that I want a machine with one CPU, but I want 8 gigabytes of RAM. Sorry, I need more CPUs for that. So 6.5 gigabytes of RAM running on container optimized OS. So what will happen once I click create on that cluster is the Google backend will provision worker nodes of the size that I mentioned here. It will actually do and create 2 of them, and will boot them with an image of an OS that's called Container Optimized OS. Container Optimized OS is a very minimal Linux distribution, really optimized just to run containers. So this is what we will provision on those nodes, and we will install and configure Kubernetes for you on those nodes. Something that you might have noticed, I'm talking about worker nodes here. I'm not talking about master nodes. GKE actually abstracts from you all of the management layers. So the Kubernetes master that you will be connecting to, and all of the etcd clusters and everything that goes in the back end is actually provided by Google. So this is not something that you need to size. This is something that will auto scale and that is abstracted from you. So you can actually focus only on your worker nodes, only on the actual resources that will be handling your requests and that will be running your workloads. That's the resources that you care about in the first place. So now that we have 2, we will go and turn on some beta because it's a demo, might as well turn on beta. So I can ask my nodes to be automatically upgraded. That's for minor versions. Obviously, if we move a major version, we will not automatically upgrade because that might break things. But automatically upgrade nodes will move between major version, and we will enable automatic node repair. So if monitoring shows that your node is having a hard time, it will actually rotate that node. We will go here and actually make that cluster highly available. As I said, the goal here is to deploy Kubernetes in a production grade manner. If you want production grade, you cannot have only one availability zone use. You need multiple zones. So I will come here and say that I will also run it in US1 East B. So I will be in the same region, all on the East Coast, but I will have 2 hosts in each of the zones. So 4 zones total for 4 vCPUs and 26 gigs of RAM. Right now I'm using Google Containers Engine multi-zone federation. If you wanted to federate that cluster with an on-prem cluster, with a cluster running in another region, in another cloud provider, you can actually add another layer of federation the same way you would federate a normal Kubernetes cluster. Again, it's open source Kube, yet there's nothing weird going on. It just allows you to create your node pool highly available from the start without having to worry about federation. The rest is not all that interesting. So what I'll do here is actually click create. And now Google is working on deploying my cluster. What happens when Google deploys my cluster? A few things happens. First thing, it is in the backend deploying that master and that management layer we mentioned earlier. So it's provisioning etcd on Borg jobs. So behind the scenes, you don't see those. It's provisioning the master. It's giving you access to that master. creating the rules for role-based access control, and that master is creating all of the master. In parallel, while it's provisioning that master, that management layer, it's actually also booting your worker nodes. Your worker nodes will be standard VMs, so nothing special, nothing that is out of the ordinary. It's just standard VMs that will be provisioned with container optimized OS and have Kubernetes set up to talk to that management layer that was just provisioned for you. And to show its normal VMs, I could actually come here and just SSH into one of those VMs. And as I SSH into one of those VMs, you'll see I'll have a very standard Linux with all of these standard Kubernetes processes running. It might have been just on this side of, I think, finish to boot. Okay, here it is. So if I come here, you can see that I just have all of it's the standard Linux. It's a container optimized OS, and you have all of your daemons. If I wanted to customize the Kubernetes deployment, if I wanted to drop anything on those VMs, I could. We don't recommend doing it that way. There's other way to automate modifications to Kubernetes, because otherwise you might be losing some features when you auto-scale up or down, but this is something that can be done in standard kube. So while those instances are finishing to boot, it will take maybe a few more seconds. We'll go back and look at the status of our cluster. So I'll come here into Container Engine, which was not in my shortcuts. Container Engine right here. And we see that the cluster is still booting. Something that's extremely interesting here is as the cluster boots, as those nodes come up, it actually integrates automatically into Stackdriver monitoring. So I can monitor the resource usage of those VMs. And it integrates with Stackdriver Logging. So if I wanted to see the logs on my hosts right now, I could come here into Stackdriver Logging and choose not firewall rules, but my cluster, Kube Toronto, and come see in the zone C what's going on. I will see that the cluster is booting. And as I start adding containers, start adding pods into that cluster, I will be able to go and see even the logs of those pods. So all of the pipeline to bring your log to a centralized location is built in, and all of the pipeline to monitor metrics on your instances is built in. I will not have time because I'm holding you from getting pizza to show you monitoring, but if people are interested in seeing monitoring more in depth, come talk to one of us from Google. We can show you more in depth what you can see in Google Stackdriver monitoring. So why I was showing management, if we go back to, sorry, not compute engine, container engine, we'll see that my clusters is still booting. So we probably need a few more seconds. There's a few hosts being booted. What I'll do, I'll go and, oh, here it is. It's getting almost ready. So I'll start my Cloud Shell, and I will start a shell that will allow me to interact with that cluster. So we'll establish connection with my Cloud Shell. I will clear the tests that I did because it's live demos, but I at least tested it. So what can I do here? I can come and tell my API management that I am the US East 1 C zone. So I will set config set compute region US East 1. I will tell it that my zone is US East 1C. This is the primary zone where I started it. Remember, we have worker nodes in two different zones, but it's the main zone. And once this is done, I can actually just tell Google to authenticate me to that container cluster. So container clusters get credentials and the name of my cluster, which is Kube Toronto. So what did that do? That actually created a kubeconfig file that allows me to talk to my Kubernetes. So all of the authentication is done through the Google API. You're authenticated using your Google account that I was logged in my shell. And now I can start interacting with my container cluster the same way I would normally. So if I want to go and see my pods, there's no pods, so that's pretty useless. My first one was supposed to be nodes. So if I come and see my nodes, The first call is slightly longer. It requires some exchange of certificates. It requires some authentication, so it might take a few seconds for it to show my nodes. But once I've had that first initial handshake, we'll see that the commands go as fast as I'd expect them to go. So while it's getting my nodes, what can I do with that cluster? So I probably have about 10 seconds left on that. Oh, here it is. I have my 4 nodes. I could come and scale that cluster up or down. I'll actually go and scale the cluster down. Let's say that I add two nodes per zone. I want to go down to 1. I will come here and just save. And Kubernetes will actually, well, Google Container Engine will actually go and scale down my cluster. So it will take a few seconds. It's fast because there's no app running now. If I had app running, it probably would have taken about 1 minute to 2 minutes. The reason for that is when we do scaling operations, especially scaled down operations, there is more intelligence baked into the product than the standard just shut down random hosts. GKE will monitor your host, find the least, the one that are under the least load, and will migrate the pods to other nodes before shutting down the nodes. So there's actually some intelligence. It's not just pulling the plug on some nodes. The migration will happen before you shut down the node. This is why if I had application running, there might have been a slight delay. I will go, and we see that I have 2 nodes that are not ready now because those 2 VMs are shut down. If I give it a few more minutes, they will actually disappear from my cluster. So now I have a cluster running, just 2 nodes, but that's okay for a demo. What can I do? I can come here and create a deployment. So I have a very simple deployment. That deployment is just one Nginx pod. It's actually the deployment from the template on the Kubernetes website. So this is extremely simple deployment. What it's doing now, and I've just been notified that pizza is here, so I'm closing down. Just give me 1 more minute. So if we go and see the pods, I now have my pods running. There's 3 replicas. I actually have 3 pods running. Something else that's interesting, we actually added some layers around the Kubernetes API. So you can come and monitor the workloads and monitor what's running directly in the Google UI and capture this via API also. So if you want to use the Google API to see what's running on your cluster, to get information, I can actually remove this filter to also see all of the default containers that run in system. You see that we have the standard, so we have Fluentd for logs, we have Heapster, we have kubedns, there's autoscalers in place. Everything is integrated by default, so you can go into our UI to see what's going on in Kubernetes. One last very important point, GKE also comes with a built-in ingress controller for Google load balancing. So if you want to leverage Google global load balancing, which is a very, very cool tech. It's not what I'm here to talk about, but look at Google's load balancing tech. It's really interesting. You can actually create backends and front ends in Google Load Balancer directly from your ingresses. And this is something that you don't have to add. This is a controller that you do not need to run on your nodes. So it will not require any additional resources. It's built in and it will create load balancing with globally available IP addresses, all of the nice things around Google's load balancing offering. So since Pizza is here, I will not stay between you and Pizza. Any questions, anything? You can also go and see my my colleagues who are on site if you want, if you have any questions.
So we can also ask questions via the mic to Patrick directly. So does anyone have any questions? No? Come on. Okay, hang on.
Thank you, Patrick. How would you recommend DB schema migrations in Kubernetes?
Database in containers are always a complex subject. I would need more information than just that question to answer in depth. Normally, depending on what you're planning to do, I would probably recommend not running the database itself in Kubernetes. If you're running on Google Cloud Platform, there are ways to do this and integrate with some of our other DB products. Normally, just in terms of storage, in terms of normally I've had bad experiences with databases and containers.
Sure.
Doesn't mean it can be done, but yeah.
It was more, I've got application version 1, which has a certain database schema, and I'm upgrading to application version 2, which is talking to an external MySQL instance on Cloud SQL or another VM somewhere. How would you go about managing the change between those two schemas?
Understood. Sorry, I had misunderstood your question. This is also something that's challenging. What I would recommend in that case, Kubernetes itself will not solve that problem. So you need something around Kubernetes to help you with that. There's a project that's been open sourced by Lyft and Google a few months ago that's called Istio, I-S-T-I-O, which actually has features to allow you to do that. It has a lot of nice features. It also has service mesh, but something that it allows you to do is to create multiple versions of your application and migrate the traffic from one version of to the other. So what I would probably do is use something like Istio, embed it in the code so you can actually migrate the traffic cleanly from your old version to the new one, rather than try to do a live upgrade of the schema. There's a lot of caveats to that. It's a very simplistic answer to a complex problem, but that's where I'd start. It has features that are similar to what we do in App Engine for multiple versions and service control that way.
Thank you. Anyone else? All right. Thanks so much, Patrick.
No problem. Thank you. Enjoy your pizza.
Thanks.